So let's start.
Let's start. So how's it going, Gil? How are you?
I'm great. Like I said, it's pretty hot in here, but that's why we have air conditioning, and I'm surrounded by sort of cool air. How are you?
I'm good. Everything is well. We're not so hot here. I'm in Minnesota, in north central United States. Everything is pretty fine right here. So for those of you who don't know who I am, my name's Todd Gardner. I'm the CEO and founder of a company called Request Metrics. We do product analytics and client-side observability, monitoring your systems from the end user's perspective, like directly from the web browser and how their things are going. And my friend Gil.
So I'm Gil Zilberfeld. I come from Israel, and where it's hot. And I'm a trainer and a consultant for all kinds of things that you want your software to be better at. So that's development, testing, agile stuff, process development. And what we're going to talk about today are APIs and what happens to them in the wild, how we can feed back information we get in production back to the cycle of development and testing. So why do we do that? So I was thinking like my old stories, and I work a lot with developers and a lot of the teams that I work with like build their own APIs, and they get like kind of spec of this is what the API should do. And when they do that, they have a lot of assumptions about how this will work. Like we build our own model in our head of how things will work, like how much it's going to be used, who's going to call it, when. And a lot of the time, these kind of assumptions, like we kind of lead them not only to the code, but also for how we test that. So we think about what
assumptions are always problematic. We're never quite right with what we think is going to happen.
Yeah, but we have to deal with something. So we got to build our own model to do that. But then we go into production, and then find we're sometimes right, but a lot of the time we're surprised, right?
Which is, it's the, like you said, you work on like agile things and agile like training, and that's very much an agile mindset of you have an idea, you throw something out, you see if it works, and sometimes it does, a lot of times it does not. And you got something wrong, it's going to break some way you weren't expecting it to, or the users are going to do something crazy, like call it, with weird headers, or, cache the results too long, or silly things like that.
I usually use this like person pressing a button like this. Like nobody will do that, right?
Yeah. There's a front end user experience concept called a rage click, where a user will be frustrated with like how some interaction is going, and so they'll just click over and over and over again, really like to express their frustration out on their keyboard or on their mouse. But it can, if it's generating API calls, it can do weird things.
So when we were discussing on having this kind of session here, we were talking about, well, that's the first step. First step is like we're sort of experimentation. We don't really think about it as this, because we're going to build the right thing for everything, right? But then you kind of say, well, if we do that, how can we continue the feedback loop back to the product? So Todd, being the CEO of a company that actually looks at APIs in production, we thought about, well, what can we look at and what can we learn from this thing that we can observe? So yeah, what do you see in production, Todd?
So in production, like there's like three main like top level things that I look at in production to like assess like that overall health. And there was this great talk like from a monitoring convention like 10 years ago, and it was the RED approach. I don't hear it talked about a whole lot, but it kind of stuck with me. And it's rate, errors, and duration. Is like, what's the rate your APIs are called? So how much traffic is coming in, calls per second, stuff like that. Errors, what kind of status codes are coming out of it, and the duration, like what's your like 75th percentile of response times across it. And that's
Mhm.
like this really interesting, like top level idea of how things are going. But then to like suss out those assumptions, you need to drill in when something is going weird, when like the rate is going really high or you're starting to throw errors, being able to drill down to like individual APIs and individual calls and see like, oh, this is weird. Like to the earlier comment about like rage clicks, I had a customer who had basically this form validation. So they would be typing into or the user would type into a search box, and then it would like pull up like quick results or whatever. And so every key press resulted in an API call to like, hey, is there any search results for this? So that API needed to be fast, but they had some expectations of the user isn't going to type more than 150 words per minute, and here's how many users we're going to have and stuff like that. Except that was very untrue when users started like rage clicking and just like mashing the keyboard because things didn't work out. Or there were bots that started scraping their API.
Oh.
And so now that you just have like robots hitting this thing and typing in characters as fast as they can, and the APIs just became overwhelmed. The number of calls was like 100x what they were expecting it to be. And so then, the performance would fall over due to underlying database constraints and all kinds of other things. So understanding some assumptions about real life usage and how something is interacted with, their assumptions were terribly, terribly wrong.
Yeah, I want to say, first of all, I didn't flip to the second one thing that we're going to talk about, and we are discussing already, that when we're talking about observability and what we can learn from a system, there are tools out there that will tell you how system works, right? Like we talk about operation tools, DevOps tools that will tell you like how your memory is doing, how your I don't know, IO, stuff like that. But what you said is very important because some APIs are going to be like used a lot, some of them are not. And if we want to like think about our application, how we can improve it, or how we can even test it better, we'll talk about that as well. We need to get down from the system level to the feature level, from the feature level to the API level. So
yeah, so much about like
go
the
ahead.
term monitoring is rooted in like infrastructure.
Yeah.
And that's generally not how I think of it. But a lot of people, when you say the word monitoring, they're thinking about, oh, we're putting like Nagios or NetData or, some sort of like server side logging so that we know, hey, how hot is the CPU running? Are we, is the heap overwhelming, or are we, is the heap too full? Is it out of memory? Are we paging? Is the disk IO overwhelmed? All of those basic things. And those are all super important. I'm not trying to say you don't need those. But what I think is more interesting is taking a user-centric approach rather than a infrastructure resource-centric approach. Like there could be lots of reasons why a CPU spikes, right? It could be nothing to do with your API at all. It could be like, hey, somebody forgot to turn off like auto update, and now this thing is downloading and patching itself when, at your busiest time. Or maybe it got hacked and like somebody's, mining a ton of Bitcoin on it or something like that, which, is very
still old school thinking antiviruses, but yeah, okay.
But I prefer to think of to approach monitoring from the end user's perspective. So how often are users calling the API, and what kind of response codes are they seeing? What is the 75th percentile of performance? So like when I say percentile, like generally when we're dealing with end user data, we're dealing with like hundreds or thousands or hundreds of thousands of like records, and we're needing to like make sense of it. Not everybody has the same experience. So we try and figure out like, all right, averages tend to hide a bunch of data. So we try to avoid averages. And instead we think about like, what's the median performance? So half the users have this performance or faster, or the 75th percentile. So 75% of your users have this performance or faster, which is a very common measurement of performance. And so we tend to look at that rather than how fast a server thought it was returning results, because it reflects what the end users actually think.
Yeah. So we're talking about like what we can measure, and basically, well, we can measure what we want, but the cool thing is like it's the feedback thing. What we can learn from it, how can we improve our setup, our configuration, our application, fixing bugs maybe, we'll talk about that as well. We can make a lot of decisions based on what we see. And it's important to see, I think, like at both levels, both the system level, which is operational level, it's important. We still need something to run at some, I'll call it a sort of average or better way, but this is like averaging on top of the entire application, right? We want everything to run well. But above that, we want some features, some APIs to run at a better level, at a better quality level that we expect.
Yeah, not all the APIs are equal, right? There are some of the APIs that you build, depending on the system, are like core critical functionality. Like this thing has to work every time. It's got to return fast. And if it doesn't, the user's experience is fundamentally broken. And then there's other APIs that are less important, right? Like it's a background polling API, or like, you know, fast search results API. And if those things go down or are slow, like it sucks, but like the user can still accomplish their task.
And I want to say about this, sometimes we don't know that when we're building this stuff. We kind of think everything is going to be important. We're going to put a lot of effort into that. Some of them we know, like what the polling thing, like we know it's going to be like happening once a day. We probably need to put some effort into that, maybe in testing to make sure it works, but not like the other stuff. But most of the other stuff, we considered it like everything's going to be the same. We need to put a lot of effort to make sure that everything works. We can't really do that. We need to prioritize, we need to test more, do like reviews for more stuff, but we don't know that on the first phase. And this is like coming back to the feedback thing. Once we learn about the usage, we can deal the cards differently. Like say we can put some focus on these APIs and less on these.
Right. And so when we're approaching testing and how we think about it, like there are some things that we know upfront that we need to test for, right? Like you need to test for like users sending garbage data, because eventually, you know, some user is going to send garbage data. So you need to have those basic tests in place of like, hey, what if I send undefined? Hey, what if I send empty array? Hey, what if I send a SQL injection attack kind of thing? Known things that you can expect to test in your API. But then there's also a bunch of stuff you don't know. Like you can't really conceive of how this thing is going to be used in every potential way. And so that's where monitoring of usage really kind of plugs back in. So it tells you about the unknown unknowns. What don't you know about your users and your system, to plug back in and then add those tests as you go.
Yeah. Plus, on top of that, things change over time, right? So you have like, once something stabilized in your system, you have features that everybody's using and they're okay, you can divert efforts or experimentations to other APIs as well. So it's not like you're getting a snapshot and just looking at it, say, well, this time we're going to do this. No, over time, you learn how your system works and you can change whatever your efforts are and what you're doing in terms of development and testing and even monitoring, because things change. Not just from the outside, like more users, hopefully, and more features, hopefully, but also about how stable the system is, what is working, what is not working. We can learn from that and have more information coming from the outside, as long as it is possible to have this kind of information and feed it back into our process of development.
Right. So I think now would be a good time to maybe show off one way you can get some of this information. What do you think?
Sure. I have a special thing for that. Yeah, demo.
Yeah, demo. Demo. Sweet. All right. I'm just going to do a real quick thing. This isn't a whole deep dive here.
I think
I got to take over your screen.
Can you? I'll stop sharing for just to make sure that you can.
Cool. I think my screen is being shared.
It is, at least I can see it.
Cool. Well, I'm assume that everybody else can see it as well then. All right, so this is request metrics. So this is the thing that I built. And so this isn't like all kinds of monitoring for everybody kind of thing. My perspective on this is how can we monitor the actual end user's experience? And right now I'm focusing specifically on APIs. So this is monitoring that's on one of the other properties that I run called Track.js. And it's monitoring how the end users from the website are actually calling our APIs and then breaking it down in various ways. You'll notice that this top panel here is basically red, that rate, errors, and duration. It's like how busy is the site over the last 7 days? How many requests are coming in a minute? What status codes have been returned? So if things start throwing 400s, start throwing 500s, and how the performance is breaking down. You'll notice that just like I was describing earlier, not everybody has that same performance. There's always going to be a spectrum of how many users are good, how many users are slow, and understanding where that breaks down is interesting. But your users aren't just in your data center. This is one of the things that I think is really interesting about a user-centric approach is that when you're monitoring your APIs from the server side, you're thinking about like, hey, here's where your data center is. And like you're monitoring the things you can control, but the users you can't control. And you need to know where your audience is. Sometimes that's really valuable. Like if all of your audience is in India, well, you really only need to care about India users. But if you're a worldwide thing, well, you kind of need to know what everybody's performance is everywhere. And so for the last 7 days, I have a lot of traffic from the US, but I also saw a ton of traffic coming from UAE, which is interesting. So now maybe I could like dig in on that and see like, well, what was their experience? So I'm filtering down to that and I could see, hey, what's the performance? It's definitely not as good. There's a lot more users that have a slower experience, coming in from UAE. And then we can like dig in on this to figure out like, what are the interesting patterns here? So when I'm monitoring from the client side, it's not just necessarily my APIs that I capture. I could capture anybody's APIs, anybody that ends up getting called, which sometimes includes things like analytics, your third parties, that sort of stuff. But so I'm going to filter and say, show me my APIs. And at least for the last 7 days on my own domains from the UAE, they were all 200 response codes. Everything was good. Nothing broke. That was great. But I did have a bunch of times where an API took more than 10 seconds to return, which is pretty crappy.
Yeah.
So if we want to dig in and understand why that happened, there's a couple of bursts. Like it's not steady. There was some bursts of traffic that happened on the 17th and then again on the 13th. And it's always to this initial page. It's a get to the root of the API. So we could look at that and see, tell me more about that. Tell me what kind of connection was the user on that caused this slow thing? They were all on broadband or fast broadband connections, so they shouldn't have been slow. And we can actually look at it and see where, like, what is this call, this specific call look like? How big was it? It was for whatever reason, a giant response payload. In this case, it wasn't. I mean, 21 KB is big-ish, but not huge. It returned text HTML, which is normal for this API, but like sometimes you can suss out that something is going wrong if it's returning text HTML and it's supposed to be JSON or XML. And then I can show you where this fits in the overall timeline, because from the client side perspective, an API call does not exist in isolation. Usually the front end experience will be like, I'm going to call API foo, then API bar, then API baz, and I'm going to stitch that data together to tell an interesting story. And I can see where this falls in. And so this API call just took a really, really, really long time, but it was well after the initial page load. And then the user made the call again, and it only took 785 seconds. So maybe this was an end user issue. maybe this was like the server was like recycling at the time. It could be a couple of different things.
And
it doesn't look like a
I want to
systemic.
stop you for a minute. This is something that, like you said, these are the unknown unknowns. How is it possible to think about this happening in the UAE, specifically on this API? So the chance of you directing any testing for that API just from the beginning is pretty low, right? So it's not something that until you see it, how it's actually running, you can actually do something about it.
Right. Yeah. Like, would you have expected on the front end to have requests coming in from the UAE? Like, what happens if somebody has like a low latency connection, or what maybe you, this has implications in testing other parts of your application? What does the user experience look like if an API takes 10 seconds to return?
Yeah.
Like, that's like, what do they see? Do they see a loading spinner? Do they see a broken page? That could be any number of things. So we could go back and we could explore any number of other things. There's also a handful of 400s. So if we want to like look at those, we could filter and say, show me the times when a user made a 404, which is, you know, not necessarily a problem. These are all things that like, yeah, those pages probably don't exist. This was probably some bot crawling me. But if there was a 500 return, I could see exactly where that was coming. Oh, I can see, yeah, this all came from web page test bot. Looking for things that don't exist. So I could dig in and I could find out what are the actual problems that the end user is experiencing from where, and see how it impacts their world, their universe. Let's see if I can find, if I go over here to the last 90 days. No. There's some. All right, here's another property that I run, remote.js. This one has some problems with it. So we could dig in and we can look at those 500 status codes and see exactly why that happened. This is
so 500 is something that's happening on the server side. From the outside, the only thing that we see is some kind of error appeared inside the server, but unless it was reported back, we don't know anything about it, right?
Right. So 500 being like an HTTP response code, 500 is server error of some kind. Now, it might have been in your API code, so you might have like an exception in your logs, but it could also be an error because a load balancer was improperly configured, or it could be an error because some other middleman proxy between the end user and you failed for some reason. So when we talk about a 500 error from the end user's perspective, it's something in the chain of events that powers your API blew up. And to the end user, it still looks like you were offline, that there was a problem, but it may or may not be your code, but it's something with your configuration.
And from the developers and testers inside the organization that develops this stuff, usually it comes back with, like you said, it's in the logs, right? You probably want to see what's happening there, start reading logs and stuff like that. If it's there, maybe it's not there. So yeah, finding out where the problems are, it's like something in the beginning of the feedback cycle. But if it, like we said, it's something that appears in production rather than in what we conjured up as test cases.
Right. So this is a real 500 error where it's not returning a content type. Like the server is just dying. It's not returning a content size header. It's not returning a content type header. It's just dying. And it's preceded by a bunch of other errors on the client side. So the ecosystem, or the place where this thing is running at the time, is kind of in a broken environment. But it's a broken environment that really happens to some users, and something that should plug back into our test cycle of like, okay, what happens if the user is in this weird broken state and then they call our API? What does it do? Why does our code blow up as opposed to handling it gracefully and sending a 400 style code or some sort of fallback? some sort of fallback experience for that end user so that they don't just think we're amateurs with a broken system. So that, I mean, request metrics does a bunch of other stuff that, you know, is a little out of scope for our API webinar, but it also does monitoring of client-side errors and security threats and product analytics. What are your users doing? How are they converting? That sort of thing, and general performance that we could talk about some other time if you're interested in digging in. But that was the large demo of API monitoring from the end user perspective that I wanted to show.
And we usually talk about testing in production and stuff like that. This is a very useful tool for that, right? It's not like it sits there and records everything, whether it's user or like you're putting a segment of what you're actually interested in and recording that.
Yeah, there's an anecdote that I've heard said by a number of different people, but like any sufficiently advanced testing setup is indistinguishable from monitoring.
Oh, nice.
Because like if your testing gets so good, if you're so thorough, then you're basically just testing the real production system and you can see everything. But there's like this spectrum that user monitoring and system testing are like kind of on that same spectrum of activities, and they plug into each other, but they also fuel each other. Like the things that you test for, you should be monitoring, and the things that come out of monitoring should feed back into your test cycle.
Yeah, I agree. Because when we talk about monitoring, it's about flushing up all kinds of data. What you see with what you do with the data is what you want to learn and make decisions based on that. So let's talk about what you can learn, what you can do once you see these numbers. So we already saw that the error stuff, right? And we usually think about, well, if we see error in production, we'd like to fix them. And that could be obviously something that we can do, but let's take it a notch a bit before that. So in terms of bug fixes, what do you do then? Well, you've identified something in the wild. Now you can take this kind of information and try to reproduce it in your testing environment. The one thing that we don't ever do is test like in production. Like we said in the beginning, we think about how it will actually work there while it would run there, but we don't have like users from the UAE when we're testing, unless we're testing in the UAE. Even then something like that probably will not happen because we're talking about more remote call. So once you have identified this kind of problem, we can feed it back into your testing cycle. So you will test that how, not just reproduce it, test that it will not happen again, make the bug fixes there. So this is one of the things that you can actually take back, but you can do a lot more things. We can talk about microservices, for example, right? Microservices are like an internal structures of what you see from the outside. But this is basically grouping of APIs. So you can group or ungroup based on usage or what you see, things that are working together or actually working together, not what you just thought will do that. So you can actually make design and architecture changes back based on what you see. And again, this is, I'm going to return to this all the time. What we think will happen is not what is actually going to happen, right?
Right. So we could group together our APIs and just we could just sort it based on usage, and there'll be, you know, like tiers that will naturally emerge of like, here's these APIs that are called, you know, 1 million times a week, and here's an API that are called a couple 100,000 times a week, and here are APIs that are rarely called. And so you could batch them together into different parts of your infrastructure supporting those loads. Or we could take, you know, a lot of organizations do with microservices do like geographic distribution. So you're using like a serverless architecture or something like that. You're putting your stuff in different regions around the world. And by looking at where your users are actually calling from, you can optimize that. Like, did you realize how many of your users were coming in from UAE? Maybe you should have something in the Middle East that is geographically close to them so that they can, you know, not have to travel so far across the internet. You know, the speed of light is a constant. If you're making everybody go to your data center in US East 1 or whatever, like some people are just going to have a worse time because they are farther away from it.
Yeah. So feeding back into our product means also operation decisions, right? Like putting up the servers locally or more closely to where the APIs are actually being used. What else? You can see what's being used, and therefore we can build on that. Like apart from operation, you can map APIs to features. Hopefully you've done that before. And once you do that, you can say, well, these features are being used more than other features. Let's see what we can do around this. And you can look at this at the API level, like we saw, and we can build on top of that. So that's one thing that feeds into the development. The other thing, like going back to bug fixes, is something that we talk about bug fixes, like we equate that to quality, but we already saw a couple of things that we could define as quality. What is the quality we need for people, but not just everyone, like different users in different areas, for example, different segments of people with different features. So we can define quality, because once we see it, it's like load testing. Like I always give this example as load testing. How do you know the threshold that you want your system to work with? Well, unless you actually do that and see what's the usage, it's just a guess, right? So usually what happens is that you run a test, you see, or in production, see it's not working for, it's now working for 10,000 people, but it's no way it's going to work for 1 million. Then you can make a decision. What will it take to have this million people supported? So again, feeding back from what you actually see, actual measurements, into your development and testing cycle.
That's a really interesting connection with load testing, and tying that back to like known unknowns and unknown unknowns. Is when you're doing load testing, you know that your system is going to go under load, right? And so you use something like JMeter or Load.io or something to generate this load on your system to make sure you can handle, 1,000 concurrent users or 1 million concurrent users or whatever you're going for. But like, there's something inherently artificial about those load tests, right? Because they're all doing kind of the same thing at about like the same cadence. It's hitting your API like as fast as the platform that you're running on can hit it, kind of thing. But that doesn't reflect what a real user usage pattern looks like. Real users are going to happen in fits and spurts, right? Yeah. It's going to be like nothing, 1,000 requests, nothing, 500 requests, nothing. And their experience will be different than what your load tests say. And so that's where we need to tie that back and see like, what's that distribution of performance? Like, is it really big where you're having a few people have good, a few people have okay, a few people have slow, and a few people have terrible, because your performance is like degrading as that happens? And just plugging that back in and grounding your load testing in the real usage patterns is interesting and can reflect back on your tests and whether or not they're accurate for production.
Yeah, so let's take that, and you can take that in terms of functionality. Is it being used exactly as production? Are we testing like it's being used? Or is it the same data? We tested with some kind of data. A lot of the times we're testing with a database that is reset every time, so we don't have a full database or full storage or stuff like that. Well, in production, you collect and collect and collect, right? So are we testing the way that it is being used in production? So feeding back into the testing plan, how are things being done in production, what we can learn from that, in terms of quality basically tells us, it gives us confidence, right? It's going to be okay in production. So if we're testing like things are going to run in production, our confidence gets a boost, let's say that. Scaling, obviously you can scale, but it's not just scaling according to system things, CPU and heat and stuff like that, but in terms of API, like we talked about, like organizing the design or the features, you can actually put more containers around APIs that are being used more, so you can support more users rather than not just like multiplying everything for every API out there. So enough information feeds back into our cycle. And last point I have is like time-dependent tests, different users hit your system in different cycles, different times. You want to test that, but it's like, again, going back to, can we think about all the kind of sequences and times and think about what's it like? Probably can't. But when you see things happening in production, you can actually take them back into your testing and create a better testing experience, therefore making better decisions once you see these things like before release.
I just want to, one last thing I want to touch on this topic is we're kind of talking about like all the different things you can learn from that production data, but I want to just kind of point at like the root argument that I think we're both making is that you as developers, you as testers, you as the people who are like actually changing the system, you need to be looking at this monitoring data. A lot of organizations, they'll be like a NOC or like an operations group or something like that, and they're responsible for keeping it online. But as developers, it's really important that you look at this data as well, even if you're not responsible for it day to day, because it should inform what you're doing. Like, this is the source of truth. Any other assumptions you have or that you're making as you're putting together your architecture are fine starting points. But when you go and look at the data and the data says, oh, this API that like I don't really think about much is like by far the most often used thing, that should be something that fuels your development time, your development prioritizations, how bulletproof you're making things to focus on the stuff that actually gets used the most and in the ways it gets used. So you as developers need to have access to this data, to look at this data and to care about this data.
And I want to add more than this. Like we talked about request metrics, and basically a lot of information is being collected by the system, but it's not always what you actually want to look at as a developer. So in terms of making a system more observable, developers need to think about what they want to log, expose, whatever, save, in order to feed it back into the system. Because otherwise, these are like black holes. You don't see what's happening in there, and you can't react. Again, going back to assumptions and guesses. So when we're thinking about observable and testable systems, it's not just the tools. It is about tools as well, but it's also about making the system expose what needs to be exposed in order to see it later. And we can't always do that like upfront, but we can do this iteratively, and we can do this incrementally. We talked about agile and stuff. This is about identifying, well, we want to look at this thing next. What do we need to do? What do we need to develop in the system in order to see that later and check that it is exposing the information that we actually need?
I want to just underline the word. I mean, we used it in the title. We probably should have defined it up front. The observability word, right? Which is tossed around a lot. Lots of different people say it, and they mean slightly different things when they say it. When I'm thinking about the term observability in its most general form, it's one of those ilities, those general properties of software, like its availability, its reliability, its quality, its securability, like all of these things, which aren't something you have or you don't. It's not like you can't just go and buy observability at the observability store. Like, it's the degree to which you can observe your system, the degree to which you can understand what's happening in production. And the more perspectives that you can get from it, the more you're going to be able to answer those questions about how your system is running. So both thinking about like, what do you want to log, and also just having a broad kind of coverage of like, hey, I just want to know how everything is kind of working so that I can ask the questions that I don't know what to ask, so that I have the data to ask that later when something's going wrong.
And even if you don't, that's still okay. You can add that, but you have to think about like this is one of the processes, and just like not just defining or developing functionality, like the non-functional stuff, right? No, we need to know how these things work. We saw some kind of patterns. We want to learn more. Therefore, we'll put more things in, more logs, more exposed data, more save points in order to return to this the next time around when we ask the question, what happens then?
Right.
And that's basically what we had for you, for the people today, right?
Well, you want to bring up the slides for our
The slides, yeah, our precious slides. So we had a demo, right? We don't share though. Hold on, hold on. Let's
Wait
share.
for it. Wait for it.
Now we see it.
You can tell that we are, professionals at this, not developers kind of making it up as we go.
Exactly. So two people and a mouse. Basically, what we talked about is basically how we look into production. This is something that, like you said, it's very important because it's not important for the operation people only, because this is the key for making products better. And in order to make product better, we can do the mapping, how it impacts both development and architecture and design and testing.
Yep. So we have to look at production, both the user side and the system side. They're both important. And if you don't have a good way of looking at the user side today, I may be biased, but I'd say you should go take a look at request metrics, where product analytics for developers, so that you understand how your systems and your users run together. And with that sort of data, you can start mapping how things are being used by your users back to your test and development efforts.
Exactly. So how to get more information? I'll start with me. If you are interested in more information about observability and testing, and how to test your system better, and how to make your design more observable for the testing people and testing information in general, Gil at testinggil.com, or at Gil Zilberfeld on Twitter, or at somewhere else. And Todd?
Gil is a fantastic trainer. If you're like trying to scale up your API practice, or trying to bring new people on board, or just get better, you should totally get in contact with him.
Thank you.
Fantastic resource for you and your company. And then if you want to talk more about request metrics, you can go out to requestmetrics.com. And if you don't like, talking to people, I totally get that. Talking to people is exhausting sometimes. So you could just go out to requestmetrics.com and start a trial, or learn more about what we do, or play a demo or whatever. But if you do want to talk to me, you can scan this QR code or go to bit.ly/suptodd, and you're going to land on a contact page where you can follow me on socials, or you can schedule a meeting with me, or send me a message, or read about other stuff that I work on.
And that's very cool. I went to this contact page as well. So it is a very cool page.
I try to have fun.
Yeah. I think it's very important to have fun. If you have questions, please put them in either the chat window or the Q&A box, so we can answer them.
Yeah, happy to chat more. We got another 15 minutes or so to answer questions or give you time back in your day.
So great session. I have to leave. Oh.
All right. Thanks. Bye.
There is going to be a recording, of course. I'm going to publish it and follow us on social media to know where to find it. So,
yep.
Yeah. If you have questions, put them now, or you'll have to resort to other text-based things.
So while we're waiting for a question to roll in, Gil, what is the worst API disaster that you have ever been a part of or learned about?
So it's not really a disaster. I'm thinking always because when I come in, it's not like a production thing. It's more towards production. And I think my worst experience was that people were the developers they were disconnected from the testers and product. So we're talking about what we talked about, like feeding back from the production back. They weren't aware of anything. All they had are like documents that an architect wrote. You should have this kind of an API. So this kind of thing, it's not like a disaster, but it's leading to a disaster, right? Because like we talked about it, like everybody has their own idea of how it's going to be and should it be implemented, and nothing more. Everything else is a guess. So yeah, and plus the testing would be like 3 months later. So yeah, a good recipe for disaster.
Yeah, I was part of a similar project once where like they had really, question came in from an anonymous attendant. I want to know how to configure with this tool. I assume with this tool, you mean request metrics. So request metrics is client-side monitoring. So we sit in the web browser itself and observe how that client is interacting with your APIs. And so installing it is like an analytics tool. You would add a little HTML JavaScript tag to the head of the page that brings down our agent. And so that can either come down like just copy and paste the HTML in, or if you're building a rich client-side application with like Angular or React or Svelte or one of those, we have an NPM package that you would include as well. That agent sits and it instruments the browser itself as it's doing things. And so it knows how long the browser took to make an API call. It knows what kind of status codes got returned. It knows what errors got thrown. It knows what the user's clicking on and what they're interacting with, and that sort of navigation. And so the advantage of doing it this way is that you don't really need to make any changes to your code in order to get this level of visibility. I'm doing black box testing, for lack of a better word. I don't want you to change your API code to see how it's being interacted with. I'm going to measure how it's being called from the outside and tell you how that's happening. There's a bunch of walkthrough videos and stuff on requestmetrics.com if you're not familiar with front-end development and you want to add that into your system. It's super easy, copy paste, go.
And this is something that it's very interesting, right? Because if we talked about observability, you have to build things into that. This is like the plugin that you wanted, right? To just patch it on the existing system, and it will just work.
Yeah. So we started building it this way because I'd run into a bunch of people that like were buying like big like APM kind of tools like Datadogs and New Relics and those sort of things. Mm-hmm. And they could only ever get that installed on what the current hot thing in their organization was, because it required so much change and fiddling and configuration to get it all working that just the old systems that weren't actively being worked on never could justify the time and the effort to do it. But it's those old systems that in a lot of organizations are the ones printing all the money. Yeah. And that's why they're still around. But there are these black holes of observability because nobody wants to touch them. Yeah. And so I can do that by monitoring from that edge, monitoring from that client where you don't actually have to touch those systems and risk anything going wrong with them. You just need to listen how they're being called. And then if they go offline, if they slow down, if they start throwing errors, I can tell you that. And you get like this broad base of observability without needing to make significant changes to your code. I thought that was a really interesting way of approaching the problem.
We could talk about this and how to refactor your system when you're doing this while you're monitoring performance. You can do this like in stages, and you monitor and track your performance and see that it doesn't go down. Yeah. So like external system.
Yeah. It's like a test wrapper for your whole system.
Yeah.
System tests without being fragile because you didn't actually configure it.
we can talk about like other metaphors as well. Okay, guys, last chance to have your name near a question to us.
Going once. Oh, here we go.
Ooh.
So performance testing can be done. Can you elaborate how? Yeah, I'll let you run that one, Gil.
Well, first of all, it depends on what you're actually defining as performance, right? Because you can even performance of the system in terms of availability. We talked about errors and 400s and stuff like that, or 500s are a measure of performance. So in production, you should, and also in testing, you should define what is important for you. Once you decide what is important, then you start tracking it. And this entire session has been about looking at the right data and what you can come up in order to monitor it, and what you can come up later when you see what the results are. So it starts with you defining, well, what do I want to track? Tools like Request Metrics help you do that, because it can track all the APIs usage and errors and stuff like that. In terms of doing performance testing before that, Todd, can you tell us about maybe your clients? What do they do in terms of just running like regular JMeter, stuff like that?
Yeah, so there's a couple of different ways that I've seen it. I mean, you can do just a base level performance test. If you have like some nasty computation or like an elaborate SQL query or whatever, like you can set up an integration test where you basically just like, all right, I'm going to, pre-set up this gnarly data and I'm going to make a call, and you just add a counter. And you're just like, okay, start stopwatch, call function, end stopwatch. The time should be less than this kind of thing.
And this would be like a low-level user-defined test.
Yeah,
right?
yeah. So like if you're just trying to performance test like how one bit of code does, you can use timers in .NET or Java or Python or whatever
language,
and just assert, hey, this is the maximum that I'd be willing to accept. Another way of testing performance is often called load performance, where you're trying to test like how well does that system do when you put it under heavy load. And then you need to get into like a staging or a test kind of environment where you have lots of users set up and like the system is in a production-ish environment or state. And then you can use tools like JMeter, which is like a Java tool that you set up locally on your system. There's a bunch of other like clones of that in other platforms. I've used a web-based system called Loader.io before. I don't know if they're still around, but I used them like 3 or 4 years ago, that let you basically define a bunch of like API calls, and then they would distribute it to their cloud and call you from all over the world, and basically like a pre-set up DDoS attack kind of thing. And you could see how well your system would do under that load. And so those are the two kind of ways that you can really write a performance test. I mean, there's lots of other ways that you can do for like web-based performance testing. But for APIs, which is kind of what we're talking about today, those are the two things I'm familiar with. But monitoring, is that real data that you plug back in to be like, okay, you tested it for 1,000 concurrent users. Now here's how it actually performs for 1,000 concurrent users.
And you can run this like also on production systems as well, right? So if you're courageous enough, and you can see how your system is working according to the test that you defined. Once you see the result, you can say, well, is this okay for me? Is this going to be okay in 3 months or 3 years? And you can set it up in order to feed it back into the system. So, well, these are the design changes or more service that I need in order to support this kind of load in the future. Then you can test that. So usually you monitor or you observe the current result of your test, and then you make decisions based on that, on how you want to continue.
And that's the larger problem that I'm trying to solve right now, is that right now you'll be like, what's the acceptable performance of my API is 700 milliseconds or less, or whatever. I'm trying to connect that API monitoring back to the rest of product analytics, so that if that API exists as part of a particular funnel, like the user filling out a form or submitting an application or doing a search or whatever it is your application is doing, I can tell you things like what's the conversion rate of people doing that. And then when performance starts degrading, I can tell you at what point did users care enough that they started quitting. So I can tell you, is your performance target acceptable, or is it already too slow for what your users are willing to tolerate?
which is interesting because you can't know every user in the world. So having this kind of information, like application specific, is very important for people.
Thanks, Amber.
Thank you,
That was a
Amber.
great question and a good conversation. I think that's probably it.
I think it is. Yeah, we're up to an hour. I think we've had enough fun.
That's enough fun for the day. It's time to go back to work.
Yeah. So Todd, thank you for joining me today, and I was happy to join you. And maybe we'll do something like this in the future as well.
Yeah, I think we should.
Running ideas. And thank you for everyone for joining in. And if you have other questions, you will have this recording and slides and information on how to get to us. Follow us on the different social media channels and check out Request Metrics because it is a cool tool.
Thank you so much, everybody. Have a great day.
Thank you. Bye-bye. Hey, everyone. If you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.